Hello, this is the EEG setup with E prime. We're using an emotive test bench for EEG acquiring signal, E prime and ERPLab to process and analyze ERP data. This is a setup for the EEG recording. I am placing tape over the electrode under the eye. It will record eye movements. Here we're checking to see if we can acquire EEG signals on the emotive test bench. We're also looking for electroocular movements to see if it's recorded in the emotive test bench. Now this is the EMOC, the modification of the emotive with an EasyCap. Here you can see all the electrode placements, the rearrangement of the electrodes from the emotive. You can see the amplifier. We're also checking for impedance. So we're supposed to be below 50 kilo ohms, and the green dots on the test bench show us that we are indeed below 50 kilo ohms. We have to measure the distance between the monitor and the subject also. So there's supposed to be 60 centimeters between the subject and the monitor. To connect test bench and E prime, we used a virtual serial port emulator. What the virtual serial port emulator will let us do is to send stimulus markers from E prime to the test bench to then be analyzed on the ERPLab. Now the subject is performing the go-no-go task. He has to press the left mouse button every time the green dot appears. If a red dot appears, he will not press the mouse button. Also, the subject has to count every time the green dot appears. So at the end of the experiment, the subject will have counted at least 20 green dots. Also, you're seeing that the subject is getting feedback, he's receiving feedback. These are the practice trials, while on the experimental trials, the subject will not receive feedback. This is the frontal view of the subject while he is performing the go-no-go task. This angle was recorded with a Logitech webcam. So now we're doing the ERP analysis. I'm importing the EDF file from Emotive Test Bench that I saved in my desktop. Now we're looking for the file, for the EDF file. We're opening up the EDF file in the ERPLab. And remember, we have to look for channel locations because now we don't have the same locations as the Emotive had. We modified it to get better positions to look for ERPs, especially the conflict ERP, which is P300 after a conflict task. To do that, we have to extract the columns 3 to 16 and the 36 column from the EDF files to get the markers and the right columns for the electrodes. We named the file to get a new data set. Now I'm going to use a coordinate calculator that EasyCap has on their website that you can download for free. This calculator uses the spherical theta and the spherical phi and the radius of the circumference of the head that was of the person who was doing the experiment, who was the subject for the experiment. Given the spherical radius, given the spherical theta and the spherical phi on by EasyCap, when they sent me the EMOC, they sent me a paper with the positions, the spherical positions for each electrode and the circumference of the head of the subject. I can use the calculator. You can see that the the phi angle, the spherical theta and the spherical phi angle is on the left and middle box in the application. You can see there it's negative 129 for the theta angle and 0 for the phi angle. And the radius is 8.21. But that's from another experiment that I did. Now we have to get the radius from the circumference of the head of the subject. The subject had a circumference of 55 centimeters, and we can get that radius by just doing some basic algebra. Given 55 centimeters of circumference, we can divide 2 times pi, which is 2 times 3.14, between 55, and we would get 8.75. That is 55 over 6.28, which is 2 times pi, equals 8.75, which is the radius. You can see that now I look for it on a calculator, on an online calculator, to just be sure if I'm doing things right. Then I will use the spherical angles and put them on the ERP application to set the electrode positions. You can see R given C, which is circumference, and then it gives me 8.75. You can see that I already introduced negative 60 and negative 51 given spherical theta and spherical phi respectively. The EasyCap Corporation sent me those positions of the electrode placement on the cap. So I have spherical theta and spherical phi for those positions already that they gave to me when I ordered the EasyCap, the modification. Though I have to get the radius for each subject that passes or goes on the experimental task. After that, I introduce those numbers on the calculator, and they give me the Cartesian coordinates for the electrodes, so I can then see or rightfully place the electrodes when analyzing the data. Here you can see I'm giving the channel label, which is F Z, which is the central position. The polar angle, they also gave the polar angle, and it was 90 degrees angle. The Cartesian X is in the calculator, and you can see it's 4.77. Sorry, the calculator opened up on another experiment, so I have to modify it. So you can see the Cartesian X, it is 0, which is self-evident because of the central position of FC. The Y position is 6.79, and the Z position is negative 2.21. 45 for the spherical theta and 90 for the spherical phi. 8.75 for the radius, and the channel type is the number, which is the second channel. And I do this over and over until I get to the reference, and I set the M1, which is the mastoid 1 on the left side, to be the reference. Now we're ready to plot the electrode positions on ERPLab. Um, Hopefully they're correctly labeled and placed. Um, so we can see here that the positions look a lot like the EMOC we saw earlier. We can see that the mastoids are where they're supposed to be, on the back of the head. The parietals are also on the back of the head. The ZZ is the central position. The FC and F3 and F4, we can see them. We can see FCC. We can see the Y plane, the Z plane, and the X plane. So we can be pretty sure that the electrodes are well placed and being analyzed on ERPLab. We're gonna go ahead and plot the EEG waveform. Also, I have to mention here that I have used the technique that Steve Luck published through YouTube for analyzing ERP data. Um, you can look it up by searching for Steve Luck ERPLab on YouTube, and you can see how he imports data, cleans the data, and then analyzes the ERP data. Also, he teaches you how to download the ERPLab and include it with MATLAB or EEGLab. Okay, so here I am opening channel scroll to plot the EEG waveform. We can see the event types that I labeled on E prime. So we have 48, 49, and 50 as event types. Now that we can see that I have turned the grid on, the Y grid, and we can see each channel sending out EEG data. This is raw EEG data. There are a lot of artifacts that are going to be corrected using a filter that we're going to apply later. Here we can see the markers, the event markers. Each marker presents a time point of a stimulus. So I recorded 3 types of stimulus. I recorded the stimulus presentation, so that was when either a red or a green dot appeared. The mouse press, so that was what the subject did, and the accuracy. So if the subject got it right, he got a 1, and if the subject got it wrong, it doesn't appear here. Here we can see the data a little bit cleaner. So now we're gonna create an event list. The event list helps us classify each type of marker to the correct event type. So we're gonna create that list. So when we are analyzing the ERPs, we can analyze them separately. Here, I am looking for the event types just to be sure that I'm labeling them correctly. So we're gonna give 48 marker as the stimulus presentation. We're gonna assign that marker a bin. We're gonna assign the 48 marker the bin 1. We're gonna label it, insert it, and we're gonna do that for marker 49. And also for marker 50. We're gonna save that file, which is the bin list or event list. Say that. Remember, I'm just following the steps that Steve Luck used in his video tutorials for ERPLab. Now we are going to extract the bin-based dev box. We're gonna run the analysis. You can see that it's bin-based dev box. It has been renamed bin-based dev box. I'm gonna save that data set called bin-based dev box. And now we're gonna run the filter for artifact rejection. So we're gonna use the moving peak-to-peak amplitude explained by Steve Luck in his tutorial. And now we can see the event types and now we can see the event types, and we can see the rejected time points where the frequency was too high for the filter. You can see that red space, this other red space has been rejected. We can also reject channels. If you want, you can reject a specific channel. But this time, since I have just 14 electrode positions, I'm just going to use all of the positions that I have. Now we're going to compute average ERPs, so we can see the ERP of each event type. We're going to give that ERP set a name. You can just follow what I'm doing, just pause the video and go step by step, or you can look Steve Luck's video. Now we're gonna filter that data because we don't want we want the lowest band pass passing. We're gonna apply a low band pass filter. It's gonna be 30 something decibels. We, as Steve Luck said, we should use a steep filter for these type of data. So I'm trying to push it up a little bit higher so we can get a steeper filter. Now we open up that data set which has a filter applied to it, and we plot the ERPs to see if we got something. Sorry, I accidentally pressed scalp maps, but I wanted to plot the ERP waveforms, not the scalp maps. So here we see the ERPs. We obtain some event-related potentials from the frontal positions, from the parietal positions, and the occipital position. It is more pronounced on parietal 4. We saw that on the last screen. I'm gonna try and plot just the mouse press event. Sorry, the stimulus presentation event. So this is the ERP waveform that we got after stimulus presentation. So we can see that there's there are waves, there are marked waves which have a morphology similar to an ERP waveform. Time frame, it looks like a P300. It could be like a P300, but I'm not actually sure. So this has been all that I've done. This is the whole procedure of what I'm planning to do to validate the EMOC. Maybe I would use an oddball paradigm instead of a go-no-go task, which is easier. It doesn't require pressing a button, and also it gets you cleaner data. Someone has told me that you can get cleaner data just by doing an oddball paradigm, not a go-no-go task, which requires some mouse pressing and could generate another type of ERPs. So thanks for watching. If you want, you can send me an email. The email is down below. A link for every program that has been used in this video is provided on the description down below. You can comment anything that you want, suggesting anything that you want. You can hit the like button, and also, well, thanks for watching. Remember, this is just a pilot study. It's not a complete study.